Find the general solution to the ODE y prime plus 1 over x times y equals 0. All right, so the first thing we want to do is make sure it's in the correct format, right? So we're supposed to have y prime plus some function of x times y equals some other function of x. Our f of x here is 1 over x, and our g of x is just 0 again. So the next thing is you want to compute the integrating factor. Right, so the integrating factor, mu of x, is equal to e to the indefinite integral of f of x times dx, which is e indefinite integral of 1 over x, from right there, times dx. Right, and that ends up being e to the natural log, so the integral of 1 over x is natural log of the absolute value of x, and the plus c really, but we're going to go through this problem and actually show why you don't need the plus c and also why you don't need the absolute value. You can end up dropping it. So let's go keep simplifying this. So we want to simplify it as much as we can before we multiply the equation, just to make things a little cleaner. So if I split this up, I have e to the natural log x plus c. Well, I can split that up into e to the natural log absolute value of x times e to a constant of integration c. The next thing I'm going to argue is, okay, well, e is a constant. It's about 2.7. And so a constant to the power of a constant is still a constant. So I want to simplify that into e to the natural log, absolute value of x, times a constant of integration. So we're just lumping them together like we usually do. The next bit is, well, the e and the natural log essentially cancel each other out. So this is the same as absolute value of x times c, the constant of integration here. The other thing is we can actually get rid of the absolute value. So we have a constant here, and this part's a little bit more hand-wavy, but what this ends up being is, you have a plus or a minus x, and that whole thing times c. Right, it's positive x if x was positive to begin with, but it's negative x if x was negative, right? Negative would end up being positive. It's an absolute value. So we essentially have, plus or minus x times a constant integration c. So then we write that it's plus or minus constant integration times x. And like we usually do when we lump together other constants like divisions and here e to the c into just another constant, we can essentially lump in a plus minus into the constant integration, because you either have a positive number, a positive sign times a positive constant, or a positive sign times a negative constant, or a negative sign times a positive constant, or a negative sign times a negative constant. They're all still constants. So we're just going to call it cx. And it will turn out we don't even need this c. So now our constant integration here, this is our integrating factor. And so now we're going to go back to the differential equation we had, and we're going to multiply the whole thing by c times x. So we end up with c times x times y prime, plus we have c times x times 1 over x times y equals, and we have c times x times 0 is still 0. All right. We can simplify that a little bit. So we've got c times x times y prime plus this x and this 1 over x cancel, and we just end up with c times y is equal to 0. And then the last thing we can do is we can actually just divide the whole equation by this constant integration c that we had from this bit here. So if we divide everything by c, 1 over c times 1 over c, then we just end up with x y prime plus y equals 0, right? 0 times a number is still 0. And so going back, we actually could have avoided this plus c entirely. We could have started out and said that mu of x was equal to e to the natural log of the absolute value of x plus c. We could have avoided the plus c. We could have avoided the absolute value in this case. That's not all the time though, so it's not just that your lecturer might throw a tantrum if you forget about this. It can actually make a difference in other problems, so you do need to be aware. But in this particular case, this ends up simplifying just to x pretty much, which is what happened, right? We took the original difference equation, multiplied it all by x, our integrating factor, and we ended up with a new difference equation that's slightly different. Now again, we can use the reverse product rule to essentially simplify this. So the way that's going to work, I'm going to go and start my work over here. So we have x times y prime. So what's that going to equal? Well, I'm going to do the non-derivative of the first term times the derivative of the second term, so y prime, plus the derivative of the first term times the non-derivative of the second term. So right now, simplifying that, we'll end up with x. The parentheses almost weren't necessary here, it's just y prime, plus the derivative of x is 1. So we just end up here with 1 times y. And then, simplify xy prime plus y. Right, and then the trick that we wanted to use is do the product rule in reverse. So we have this xy prime plus y. That's exactly what we have over here. And so we can say, okay, well, this thing we can kind of reverse product rule and turn it into this, xy, the whole thing prime. So now over here, we just have xy, the whole thing prime, equals 0 still. And the next step is, okay, now integrate everything. So the integral of xy prime dx equals the integral of 0 dx. The integral here and the derivative essentially cancel out, so we end up with xy equals integral of 0 is the constant integration c. And this c is different than this c, right? They came from different places, but I'm just going to use c for both. All right, so now all the derivatives are gone, all the integrals are gone, so the last step is just solve for y. So you have x times y equals c, so then y of x is equal to c divided by x. And that's it. We've solved the difference equation using the method of integrating factor.